Okay, so what I'm going to talk about today is oxidation and reduction of aldehydes and ketones. So we've already seen this a little bit. We just hadn't talked about aldehydes and ketones by name, really. So now that we've talked about aldehydes and ketones, we can look at the oxidation reduction. So remember that we can oxidize primary and secondary alcohols. Tertiary alcohols cannot be oxidized. Primary alcohols, remember carbons that are combined that have two hydrogens on them and are only connected to one other carbon and have the hydroxyl group, can be oxidized to aldehydes. So this symbol here is the oxygen. The O in the brackets indicates just a generic oxidizing agent. You don't need to remember what the oxidizing agents are. They tend to be chromium compounds and a few other things. Down here is a secondary alcohol oxidized to a ketone. So that's what we have happening when this occurs. Is we have the oxygens on the not the oxygen, the hydrogen on the oxygen and the hydrogen on the carbon that is attached to the hydroxyl group are removed. So they're pulled off, and so then what we actually get, which isn't shown here, is we get a plus H2. And so the same thing happens down here. So in both cases, when we oxidize an alcohol, we're removing the hydrogen both from the hydroxyl group and from the carbon. So hopefully you can see how that works. So we'll always get H2 out of it from there. So that's the oxidizing. So of course this gives us an can't write very well with that. And this is a ketone. So there we go. So aldehydes undergo, once we have the aldehydes themselves, the aldehyde can actually be further oxidized. So if we look here, we have an aldehyde. And it can be oxidized further to make a carboxylic acid. So in this case, the hydrogen is replaced with a hydroxyl group. So we go from an aldehyde to a carboxylic acid, which we'll talk about a little bit later. So let's proceed here. So when we look, here's the reaction forming a carboxylic acid here. Ketones cannot be oxidized, and really the point is that once when you're trying to oxidize something, either an alcohol or a ketone or aldehyde, there needs to be a hydrogen on the carbon in question, either the carbon attached to the hydroxyl group or the carbonyl carbon. If there is no hydrogen, there can be no further oxidation, because remember, oxidation can be thought of as removing a hydrogen as well as adding an oxygen. So if there's no more hydrogens to remove, then there's no more oxidation that can be done. So there we go. So the kind of things, if we want to get more specific, I can even do something like a cyclic alcohol here. And so if I oxidize this, see if I figure out how to make this a little more steady. There we go. Oops, too much. There we go. So what happens is this simply gets oxidized to a ketone. The rest of the structure stays unchanged. One other little side note is that aldehydes are actually pretty easily oxidized, and we'll talk about this later when we get to the biochemistry, but oxygen gas can actually oxidize aldehydes to carboxylic acids. This is actually part of rancidification. There's a multi-step process there, but so aldehydes usually have to be protected from the air. Okay, reduction is simply the other way. So when you think of reduction of aldehydes or ketones, what we're going to do is we're simply, just like with hydrogenation of a double bond, we're hydrogenating the carbonyl with hydrogen, and you have to have some heavy metal, usually platinum, nickel, or copper. We'll probably just stick with platinum and nickel for this class. But so, just as we saw before, an aldehyde gets reduced to a primary alcohol. This is primary because of the one carbon attached, and the ketone gets reduced to a secondary alcohol. So you see the addition of the hydrogen. So the hydrogen goes here and here, and we break down the double bond. So same thing here. We add a hydrogen here, we add a hydrogen here, and that breaks down the double bond. So here are the hydrogens that we added. Okay. Oh, that looks like I'm done. So let me do a couple practices here. So let's do a little practice here with, actually, there we go. So if we want to oxidize, so actually I have an idea. Let's consider this aldehyde here. I want you to try to draw both the products of the oxidation of this aldehyde and of the reduction. So if we add H2, what happens if I reduce it? So I add platinum. So take a moment, pause the video, and try to draw both these structures. So what we see is we'll actually see exactly the same structure. Remember, the only thing that really changes is the aldehyde part. So if we oxidize it, we turn it to a carboxylic acid. If we reduce it, we turn it back into a primary alcohol by adding the hydrogens across the carbonyl carbon there. So this hydrogen still remains. It's often not written, but we do keep it there. So I'm going to add hydrogen to this oxygen, and I'm going to add a hydrogen here. Okay. I hope that clears up some things about oxidation reduction. I guess one last thing I should leave you with. Just remember that the two things that cannot be oxidized are tertiary alcohols cannot be oxidized, and ketones cannot be oxidized. And the thing they have in common is that the carbon in question here does not have any hydrogens attached to it, so they cannot be oxidized further. So these both give us no reaction.